Hello student, how are you? I am Arunsir. Welcome to my channel Tuition Expert. Today in this class, I will teach you the equilibrium of a body along rough inclined plane under an external force. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET exam confidently with a good rank. Now let's start about the class. Equilibrium of a body along rough inclined plane under an external force. Suppose this is a inclined plane, angle of inclination is theta. Now alpha is angle of repose. I have discussed what is the angle of repose in previous video. Angle of repose. Now theta greater than alpha. Consider angle theta greater than alpha. Now if a body is placed on a rough inclined plane, suppose a block of mass m is placed along the rough inclined plane and theta greater than alpha. What happens? The body move in this direction. Now an external force applied along the parallel to the inclined plane. Now what is the minimum force? Because question is external force applied along rough inclined plane. Two cases may be arised. First, the body tends to move fast. The body tends to move downward. Body is in equilibrium but tends to move downward. That is, velocity tends to move downward. That is, body slide down. But if minimum force, a force applied along the inclined plane, keep the body is in equilibrium, but the body tends to move along downward. If force is released, then body moves downward. So this, what is the force required to keep the body is in equilibrium such that the body tends to move downward? When the body tends to move downward, now friction always act in the opposite direction. So here body tends to move downward, so friction act in this direction. This is the friction force. Now what is the friction force? Friction force we know mu into n, which is equal to mu mg cos theta, because n equal to mg cos theta. We know in previous video I have showed that normal reaction along inclined plane is mg cos theta. Now friction force equal to mu into n, which is mu into mg cos theta. Now friction force applied here, friction force acting here is mu mg cos theta, upward direction, because the body tends to move downward. So what is the external force applied? The force required will be this force plus this force, balance the body, balance the force mg sin theta. So body is in equilibrium, so this plus this balance this force, that is f plus f1 will be mg sin theta, and f equal to mg sin theta minus f1, which is mg sin theta minus f1 means mu into mg cos theta. So this is the force required. Suppose this force is f1, so f1 is this. That is, when the body tends to move downward but this force applied keeps the body in equilibrium, then the force required is this. Why? Now when the body tends to move downward, the friction force act upward direction. So this plus this force balance this force, so F1 equal to this. Now case 2, second case. Case 2, the body is at inclined plane. Here. Now force is gradually increased. So at a particular force, the body tends to move upward. So now the body tends to move upward, but the body is in equilibrium. If a small amount of force greater than F2 is applied, then body moves upward. But at this point, just body tends to move, not in motion, just tends to move upward. So if the body tends to move upward, then friction act in this direction. So this is the friction, which is equal to mu mg cos theta. Now weight act in this direction, mg sin theta. Now what force balance? Now here F2 balance this plus this, so F2 equal to mg sin theta plus F2, which is mg sin theta plus mu mg cos theta. So F2 equal to this. Now this force required when the body tends to move upward, but it is not in motion. For applied force F2, the body is in equilibrium, but body tends to move upward. If little amount, very little more than F2 is applied, then body moves upward direction. But at F2, the body is not in motion, just tends to move upward. So that force required equal to this. So F1 is when body tends to move downward, force required is this. This force required to keep the body in equilibrium when the body moves tends to up downward, and this force is required when the body tends to upward but body is in equilibrium. So this what is the now ratio F1 by F2 now equal to mg sin theta minus mu mg cos theta divided by mg sin theta plus cos theta, which is equal to, if we divide sin theta minus mu cos theta, now we know mu equal to tan lambda, so you know, so put here we get tan lambda equal to sin lambda by cos lambda. So what the sin theta cos lambda minus sin lambda cos theta divided by sin theta cos lambda plus sin lambda cos theta, which is sin theta minus lambda by sin theta plus lambda. So F1 by F2 ratio is this. This is the result. So you remember this result, you can remember this result. Lambda is angle of friction and theta is angle of inclination. So F1 is force required when the body moves downward, tends to move downwards, and F2 is force required when the body tends to move upward. Ratio becomes this. Now suppose this is an inclined plane of inclination theta. A block is present here on the inclined plane. Now here theta greater than alpha, where alpha is angle of origin, angle of repose. This is angle of inclination and alpha is angle of repose. Block of mass is placed on the inclined plane. Now an external force is applied at an angle theta with the horizontal. Now an external force act at an angle alpha with horizontal direction. What is the force required to keep the body in equilibrium? The body is in equilibrium under F. Now here two cases may be arised. Case 1, similar to previous problem, when the body tends to move downward. This case, when body tends to move downward, what happens here? Now the component F along this direction, F cos alpha, and component along this direction is F sin alpha. Weight act in this direction, mg cos theta, mg sin theta. Now case is body tends to move downward. Body tends to move downward. Okay, this is the case. Consider mg sin cos theta, mg sin theta. Okay, now body tends to move downward, so friction force act in this direction. Friction force equal to mu mg cos theta. Now this force plus this force balance this force, so we can write f cos alpha plus mu mg cos theta balance mg sin theta. So f equal to mg sin theta minus mu mg cos theta. Here component of this force, applied force along parallel line is f cos alpha and component along vertical direction is f sin alpha. Here normal direction is n, normal direction is n, so n plus f sin alpha, n plus f sin alpha balance the mg cos theta, mg cos theta, so n will be mg cos theta minus f sin alpha minus f sin alpha. This is the normal direction, so friction force will be, so friction force equal to mu into n, which is equal to mu into n. N is mg cos theta minus f sin alpha. So here friction force equal to mu into n, that is put here n. Now this force plus this force balance the mg sin theta. So in equilibrium f cos alpha plus friction, that is mu into this balance this force. So from this we get f common cos alpha minus mu sin alpha equal to mg sin theta minus mu mg cos theta. So from this we get f equal to mg common sin theta minus mu cos theta divided by cos alpha minus mg common sin theta minus mu cos theta by cos alpha minus mu sin alpha. So this is the force required when this force is act at an angle alpha with horizontal. This force required if the body tends to move downward. So when the body tends to move downward, force required is this. Force required is this. Now one result we get, if mu equal to tan lambda put here, if mg sin theta minus tan lambda cos theta by cos alpha minus tan lambda sin alpha. After simplification we get mg sin by cos, that is sin theta minus lambda pi sin lambda by cos lambda, cos alpha plus lambda. Required is this. This is the answer. Where lambda is the angle of friction, theta is the angle of inclination, and alpha is the angle of angle at which the force applied with horizontal. Alpha is here angle of external force with horizontal. Now next case, when the body tends to move upward, when the body tends to move upward. Now the body tends to move upward. The body tends to move upward under external force. Now what is the force required? So mg act in this direction, mg cos theta, mg sin theta, normal direction. Now the body tends to move upward, so the friction force act in this direction. Friction force act in this direction. This is F. Now force component of this along this direction is F cos alpha, and this direction is F sin alpha. Now here A plus F sin alpha balance the mg cos theta in, as previous problem. So n plus F sin alpha balance mg cos theta, which is n equal to mg cos theta minus F sin alpha. This is the normalization we get, and here F cos alpha balance this plus this. So F cos alpha balance mg sin theta plus friction, mg cos sin theta plus friction is mu into n is this mg cos theta minus F sin alpha. So F cos, now F cos alpha plus mu F sin alpha equal to mg sin theta plus mu mg cos theta, which we get F equal to mg common sin theta plus mu cos theta divided by cos alpha plus mu sin alpha. So put mu equal to tan lambda, we get mg into tan lambda, sin lambda by cos lambda. So this is sin theta plus lambda divided by here sin lambda by cos lambda. So cos A cos B minus plus sin A sin B is cos alpha minus lambda, cos alpha minus. So this is the result. So when the body tends to upward, the result F2 equal to this, and in previous situation we get the F1. Now here F2 equal to this, we get this result. Now third situation, when suppose this is a inclined plane and body is present here. Now F force is applied parallel to the horizontal ground, parallel to the horizontal ground. F force is applied parallel to the ground. What is the minimum force required such that body is in equilibrium? Now here theta greater than alpha, so the body tends to move downward. The body here theta greater than alpha, so the body at rest, theta here theta greater than alpha, so the body will accelerate along this direction, but a force applied parallel to the ground keeps the body in equilibrium. So what is the force required? F, find F, find F minimum force required to keep the body is in equilibrium. So now for the similarly we resolve the different component of different forces along parallel and perpendicular direction. Now weight act in this direction. So this is weight m. Weight act in this direction, mg cos theta, mg sin theta. Now force along this direction, this is theta, so this angle is theta, corresponding angle. So F cos theta act in this direction, and F sin theta, F cos theta and F sin theta in this direction. Now F cos theta, the body moves downward, so friction force act in this direction, mu into n, which is mu into mg cos theta. Friction force act in this direction. Now this plus this balance this force. So F cos theta plus mu into mg cos theta balance the weight mg sin theta. So F equal to mg sin theta minus mu cos theta divided by here now here normal reaction. What is the normal reaction? Normal reaction will be n equal to this plus this f sin theta plus mg cos theta. So this is the normal reaction of friction force equal to mu into n, which is f sin theta plus mg cos theta, f equal to this. So now here this plus this balance the weight. So f cos theta for equilibrium f cos theta plus this force mu into mg cos theta balance the weight mg sin theta. So sorry into this. So here f cos theta plus f cos theta, here friction force equal to mu into f sin theta plus mg cos theta. Now this force plus this force balance this force. So f cos theta plus mu into f sin theta plus mg cos theta balance this force mg sin theta. So f common cos theta plus mu sin theta equal to mg sin theta minus mu mg cos theta. So f equal to mg common so f equal to this by this sin theta minus mu cos theta by cos theta plus mu sin theta. Now if we put mu equal to tan lambda, we get tan lambda sin lambda by cos lambda. So sin theta minus lambda by cos theta plus lambda, cos theta minus lambda. So this is the result. Mu equal to, if we put mu equal to tan lambda, then we get the result where lambda is the angle of friction. So this force, this minimum force which is equal to this minimum force required to body is in equilibrium if the force is act parallel to the ground. So this is the answer. I repeat once again, force applied here, component of one force parallel to this f cos theta and another component perpendicular to this plane is f sin theta. Now weight is mg act in this direction, mg cos theta act in this direction, mg sin theta act in this direction. That is these are the component of mg. Now the body now if force is not applied, the body moves along the downward with an acceleration. So friction force act in this direction. Now component of this force f cos theta plus friction force balance the mg sin theta. Now here what is the normal direction? Now the body does not move along this direction, that is along this direction. So n balance this force plus this force, n equal to this f sin theta plus mg cos theta. So friction equal to mu into n. Now f cos theta plus friction balance the weight, balance the mg sin theta. So if take common f and mu mg sin theta, mu mg cos theta shift right side. So f equal to this by this by this. Now if we put mu equal to tan lambda here, we get this result. So a problem, I discuss one problem. Suppose this is a rope, this is a long rope, and now if the body is not in equilibrium, that is for accelerated motion. Now consider accelerated body. Now consider acceleration of a body along rough inclined plane. Acceleration of a body along rough inclined plane. So suppose this is a body of mass m. Here theta obviously greater than angle of repose. The body accelerates in this direction. So here mg sin theta act in this direction, and friction act in this direction. Friction equal to what? Friction equal to mu into normal direction. Accelerate means here mu is mu k, obviously kinetic friction, and n is mg act in this direction. This is theta, so mg cos theta. So here mg cos theta act in this direction, and mg sin theta act in this direction. Normal direction equal to mg cos theta. So what is the friction? Friction equal to mu k into normal direction mg cos theta. Friction force act in this direction, mg sin theta act in this direction. Now mg sin theta greater than friction force, so the body accelerate along downward. Now acceleration along downward is ma. Net force act along downward is this minus this. So net force equal to mass into acceleration. This is F net. F net equal to mass into acceleration, which is this minus this. Mg sin theta minus mu mg cos theta. So ma equal to this, that is a equal to g sin theta minus mu k cos theta. NEET student can remember this formula to solve the problem. Acceleration along rough inclined plane is g sin theta minus mu k cos theta. For smooth surface mu k equal to 0, that is no coefficient of friction, so a equal to g sin theta. Now if a body is projected upward, what is the retardation? So when the body is projected upward, what is the retardation produced? So this, suppose this body is projected upward with velocity u, what is the retardation produced? If the body is projected upward with initial velocity u, what is the retardation produced? Retardation is produced due to the two forces. One force is mg sin theta act in this direction, and the body projected upward, so the friction force act along downward direction. Friction equal to mu into n, which is equal to mu into mg cos theta, kinetic friction. So retardation ma, a is the retardation ma equal to this plus this, mg sin theta plus mu k into mg cos theta. So a equal to this. So this is the retardation produced when body projected upward along the rough inclined plane. Suppose an engine, suppose a car moves along the rough inclined plane. The weight of the car is mg and coefficient of friction between this and this is f. If the car if the velocity of the car along upward direction is v, what is the power of the engine? Power of engine, so that the car moves upward with velocity, uniform velocity v. Weight of the car is m, coefficient of friction is f given. What is the power of engine? Question. Power. So what is the force required? What is the force acting on the car such that the engine requires to deliver the power to maintain the velocity of the car along upward direction? What is the power required? The power required to prevent the force along downward direction, that force is mg sin theta 1, and the car moves along upward direction, so friction also act in this direction. Friction equal to mu into mg cos theta. Suppose theta is angle of inclination, here suppose m. Now what is the power, what is the force required by the engine to move upward? Force is mg sin theta plus mu into mg cos theta. Now this force required by the engine to move upward with velocity v. So what is the power? Power equal to, we know, power equal to force into velocity. So force is this into velocity this. This is the answer. So this power is required of engine. Now next question, suppose a ball of mass m is projected with velocity u from this point A, angle of inclination is theta. Now coefficient of friction is f. The body is projected upward. When the body returns again at A, what is the velocity now? When body returns to the point A, what is now velocity of body? We know if the velocity, if the inclined plane is smooth, then if the inclined plane is smooth, then body regains its velocity when it returns at this position. So if the velocity is u, then body moves up this, and when it returns back and reaches at this point, then velocity is u. This is for smooth plane. Because there is no friction. So if the velocity is at here is u, then when it returns at this point, this is u. Now if the friction is present, what is the result? This will not be u. So we have to calculate what is the velocity at here if friction is present. So if friction is present, when it returns at this position, what is the velocity? We have to calculate. So this question, first we have to find what distance the body can move upward. What is the distance moved by the body in upward direction? First we need. So at maximum height, velocity becomes 0. So now what is the retardation? Retardation equal to g sin theta plus mu g cos theta. I have just derived previous. Actually, this is retardation equal to g sin theta plus mu g cos theta. So v square equal to u square plus 2as. Now this is retardation, so we put here minus. V equal to 0, u square minus 2 g sin theta plus mu g cos theta into s. So s equal to u square by 2 into g sin theta plus mu g cos theta. So this is the distance covered upward. Now when the body return back, what is the acceleration? When the body returns back, that is in this direction. Now acceleration along downward direction, what is the result? A equal to g sin theta minus mu g cos theta. I have derived just previous. I have derived this retardation acceleration along downward direction is this. Now the distance covered is s. So what is the equation of motion? Velocity at here v square equal to 0 plus 2as, that is 0 2a. Acceleration is this and s is this. So v equal to this. So this is the result. So v equal to u into root over sin theta minus mu cos theta by sin theta plus mu cos theta. So u into root over, if we put mu equal to tan lambda, what the result? Mu equal to tan lambda, what the result? Sin theta minus tan lambda. So sin by cos, that is sin theta minus lambda, sin by cos, that is root over sin theta minus lambda by sin theta plus lambda. So this is the result. Okay. So when the body returns back, if the body is projected upward and again the body when returns back along rough inclined plane, if angle of friction is lambda, then the result velocity will be this. This is the answer. Student, this is the end of the class. To get such type of video and to continue the whole theory class, subscribe my channel.